All right, so we're going to review the Taylor series expansion for e to the x about x equals 0, sometimes called the Maclaurin series. I almost always call it Taylor series just because Taylor is easy to spell. Anyway, the series expansion goes 1 plus x squared over 2 factorial plus x the third over 3 factorial 6, x the fourth over 4 factorial, and so on. And this can be written more compactly as summation n equals 0 to infinity x the n over n factorial. So that's the answer. And I'm not going to make you derive this in our differential equations class, but that is the expansion for e to the x that ought to be committed to memory. Fun fact about this, which it may not have seen in Cal 2, let's take the derivative. If I take the derivative, derivative of 1 is 0, derivative of x is 1. Derivative of x squared is 2x over 2 factorial. Derivative of x cubed is 3x squared over 3 factorial. Derivative of x the fourth is 4x the third over 4 factorial, and so on. All right, 2 divided by 2 factorial, those cancel. 3 over 3 factorial, that's 2 factorial, 1 over 2 factorial, because the 3 here in front cancels. Here I have 4 times 3 times 2 times 1. If I cancel a 4 out, what's left on the bottom will be 3 times 2 times 1, and so on. And you'll notice that this is exactly this. And so this is an alternate way of justifying that the derivative of e to the x is indeed equal to e to the x. But for the purpose of this problem, the answer in blue will suffice. The Taylor expansion about x equals 0 of e to the x is summation n equals 0 to infinity x to the n over n factorial.